Okay, I'm back, and in our previous segment we talked about what the minerals were. So now we're going to take those minerals and start to put them together to make rocks. Now there are three kinds of rocks that you need to know about. So you're going to have igneous rocks, sedimentary rocks, and then metamorphic rocks. So we're going to start with the igneous rocks. So an igneous rock comes from the solidification of magma. So that you've got all of these ions and minerals that are in the liquid form when they're inside the earth, because the earth is very hot. And then when this stuff hardens, when it freezes, just like when water turns into ice when you lower the temperature. So when you lower the temperature on magma, then what happens is that these ions and minerals, they begin to crystallize and they will turn into an igneous rock. So how can we classify igneous rocks? Well, one is going to be based on their mineral content. So, for example, basalt has a lot of pyroxene in it, and it has a lot of plagioclase, and both of those are very dark colored minerals, so it's not surprising that basalt is going to be a dark colored rock. On the other hand, if you look at granite, it has a lot of quartz in it, and it has a lot of potassium feldspar, which are light colored minerals. So therefore you end up with a light colored igneous rock. Another way of classifying igneous rocks is based on their crystal size. And so in andesite, it does have crystals, but they're so small that you can't see them with the naked eye. And that's a clue as to where did andesite form. So it formed in a place where it cooled off so quickly that crystals did not have a chance to form. And so that would be at the surface of the earth in the form of lava. Now take a look at diorite. So diorite is another igneous rock, but you can see crystals in it, and that's because it formed deep underground where it cooled off very slowly, and then those crystals had a chance to form. So those are some ways of telling different kinds of igneous rocks apart from each other. Now the two igneous rocks that I want you to know is going to be basalt and granite. Basalt is going to be what the ocean floor is composed of. So the igneous rocks that make up the floor of the ocean are going to be composed of the igneous rock basalt, and the continents at their cores are mainly going to be composed of granite. Okay, now that we've got our rocks, so we got some igneous rocks, what's going to happen to them? Well, they're going to be weathered. So weathering is going to be the breaking down of rocks into sediments, into pieces, parts. And there are two kinds of weathering. Physical weathering is only going to take the rock and turn it into smaller rocks that have the same chemical composition. So one example of physical weathering would be, it's called frost wedging, in which you've got a rock and then water gets into the cracks, and then as that water freezes, it expands and it breaks the rock apart. And then during the daytime, it warms up, the ice turns into water again, and then the water seeps a little bit deeper into the cracks, and then during the nighttime, or when it gets cold again and it freezes, the ice expands, and again it breaks the rock open a little bit more. So it doesn't change the chemical composition. You know, if you start with granite, you just end up with smaller pieces of granite. Glaciers. So if you look at a glacier, for example, you start out with a V-shaped valley. So there's the little stream. So this is a mountain over here, and this is a mountain over here. and then in between is a V-shaped valley that's been carved by that river. But when a glacier comes through, what it does is it changes it into a U-shaped valley. So if you ever have a chance to go out west and look at the Rocky Mountains, you'll see a lot of examples of where the valleys have been carved into a U-shaped valley due to glaciers that came from the last ice age. Then, what's that a picture of down there under liquid water? Well, that's the Grand Canyon. So liquid water can carve up things. And then that picture that's next to it shows what wind can do. So wind can erode rocks and make them smaller. Okay, another way of weathering a rock is through chemical weathering. So in chemical weathering, we are going to change the composition of the rock. We're going to alter the minerals that are inside the rock, and we're going to turn it into something else. So the first one there is going to be rust. So whenever oxygen interacts with any rock that has iron or other metals, it can rust the metals in it. And then that is going to fundamentally alter that rock. If you watch that Earth Revealed thing, a video, there is one of the videos shows the author takes a solid chunk of granite and hits it with a hammer, and it just makes sparks. But then he finds a chunk of granite that has been weathered so that some of those minerals have been chemically altered, and he can powder that with his bare hand. So the weathering has fundamentally altered the rock. Another thing that you get is clay. So a lot of rocks, when they weather, they turn into clay. And so here in Missouri, there is a lot of clay around here. And then another thing is that water can dissolve limestone, and limestone is composed of calcite, and then that's how you get a cave. So when the material is dissolved away, it leaves a hole. That's what a cave is. But quartz is very unreactive. So at surface pressures and temperatures, quartz doesn't really like to do anything whenever it is chemically assaulted by water or air, and so it doesn't do anything. And so the quartz crystals that are in things like granite, what happens to them is they get into a river and then are transported downstream, and they end up in a beach or in a desert somewhere. So the next time that you're on the beach and you look at all that sand, well, that sand came from mountainous regions where there was probably a lot of granite that had quartz in it. So if you want to watch a video on this, there is one that's entitled Chemical Weathering on YouTube that you can watch. Okay, now what happens to those sediments? So once we have broken the rock apart into parts, what then happens to those sediments? Well, normally they're going to be transported in a river, and then they end up in a lake or an ocean where they are compacted together, and we call this lithification. So lithification is the process of taking these sediments and then squeezing them and gluing them together to make a sedimentary rock. So if you look at that picture down there, you see, for example, sand. If sand is glued together, it turns into what rock? Sandstone. If mud is glued together, it turns into mudstone. So that we can glue these sediments back together again, and then that's going to be a sedimentary rock. Now there is one particular kind of sedimentary rock that is going to be very important. That's going to be limestone. So I want to explain, where does limestone come from? So you take carbon dioxide in the air and you mix it with water. Now most of the time this is going to be the ocean. So carbon dioxide mixes with seawater, and then what you can see that it turns into an acid. And then another one of the hydrogens pops off, and you have a bicarbonate ion. And then what happens is that, in turn, mixes with calcium, and then which is dissolved in the water, and you end up with calcium carbonate, CaCO3. And there are going to be animals that are going to absorb the calcium carbonate from the water, and they'll use it to make their shells with. And then when they die, those shells are going to accumulate on the bottom of the ocean floor and are going to be turned into a type of limestone. You can also have the calcium carbonate can directly precipitate to the bottom of the ocean floor and can be glued together to make limestone. So this is going to be very, very, very important, because this is a mechanism that is going to remove carbon dioxide from the atmosphere. And we're going to find out that with Venus, something drastically went wrong with this particular process. And that's going to explain the climate on Venus. Okay, so that was a spoiler alert. All right, in our next segment, we're going to talk about sedimentary rocks. So I'll see you in just a moment.